Okay, might do a quick sound check. Can everyone hear me okay?
Yeah.
Okay, thanks, Amy. So this week we're doing something pretty interesting. That's called generic methods, and we'll also look at generic classes. So we're in week sort of 8, 9 territory now. Very useful stuff. With what we learned this week, you'll be able to shrink your code down, okay? And not write the same code multiple times to handle different situations. Okay, so this is going to be a good technique for you. Could be very useful for Summit 2 as well. So last week we did quite a big review and a recap over well over half an hour of anonymous objects, composition, inheritance, abstract classes, self-referential objects, and things like that. And we also looked at interface classes, inner classes, local inner classes, and anonymous classes. Can anyone tell me the difference between an inner class and a local inner class? Anyone remember?
Local inner class is within a method.
Well done, Wayne. Yes, exactly right. Yep. So in Java, you can declare classes inside methods, which seems pretty crazy, but hey, why not? And so that's what a local inner class is. Only that method can use that. Only that method can use that class. Nothing outside that method or outside that class can use that class directly, anyway. Okay, so week 8 and week 9 are generic methods and generic classes. I thought we might combine these two. They're only two very short lectures or short bits of lecture material. And if you people are happy, we could explore Summit 2 related topics in week 9. So we could talk about generics further. We could talk about file IO some more. Maybe, we haven't talked about typed files, but a couple of students have asked me about typed files. We could talk about those. We could talk about a strategy for handling multiple array lists of data, where you want to do basically the same operations. You want to do searches and you want to do saving to file, loading the file, all that sort of stuff. So might be able to help you with some strategies there for handling it and not have so much repeated code everywhere or so much similar code everywhere. So that's what I thought we might do if you're happy with that. Okay, we'll see how we go. We'll see how you go. We'll do generic methods and we'll see how you go. And we'll see if you want to go on to generic classes. Okay, generic methods, big topic. So we'll talk about method overloading. We'll talk about the generic method concept. We'll talk about the type variable for bounds and restrictions, type erasure and upper bounds as well. So a whole lot of related topics come into play here. So method overloading, Java allows overloading of methods. The rules for overloading of methods are the methods should have the same name. The parameter list should be different and the return type's irrelevant. So they should differ on the parameter list. So for example, we've seen to add a GUI component to the user interface. You can say add my label. And if you want to add a button, it's my button. And if you want to add something to a menu, it's menu.add my menu option, whatever. Okay, so it's the add method is getting called each time. And for array lists, we've got names. If names is an array list, .add. So we've got multiple versions of the add method there, and which one gets called depends on what's being passed as a parameter. Is it a GUI component? Is it a menu option? Is it a string? And the context of the call, what's involved in the call here. So, so this is running the constructor. It would be the same as saying this in front, which means for our current JFrame class object, which is our user interface. So this is just taken as implied. Okay, if that wasn't running the constructor, it would be added to who knows where. Okay, so you might even get a compilation error if it's not running the constructor, unless you're adding it to a panel. There might be panel.add. That makes it really clear. Okay, so that's method overloading. We've talked about it many times before, well, quite a few times anyway. And so the same method name, But which one gets called depends on context and which one and what parameters you're passing. So we saw that overloading was a great thing because it saved you remembering lots of methods with silly names like add GUI component to panel, add GUI component to frame, add menu option to menu, add string to array list, all that sort of stuff. So very, very good stuff for programmers. One of the programmers' best friend is method overloading. Okay, so parameter lists should differ, or their context should differ. So what's involved in a call should differ. And there's some examples here. So find min, you might take 2 integers. Find min might take 2 floats, and you might have find min that takes 3 integers. So they're all called find min. And which one gets invoked depends on whether you pass 2 integers, 2 floats, or 3 integers. And of course, if the 2 integers version didn't exist, the float one would get called because integers are automatically promoted to floats. Okay, so that's method overloading as well. So let's look at this bit of code here. We're doing the same sort of thing, but we've got a method called print marks. Just prints it out to the screen. The first one takes 2 floats. The next one takes 2 doubles. It's just a silly example, silly example, just to show you some overloading in process. Okay, so we've got some float marks here and some double marks. And here we're calling print marks and we're passing through the subject 1 marks, which is the floats. So this one here will get called. And here we're passing through subject 2 marks, and they're both doubles. So the double one will get called. Okay. Now there's lots of issues with this slide, and it's like fingernails on a chalkboard to me. They should be lowercase letters. And really they should be lowercase f's and d's, and lowercase f's and d's for floats and doubles. But they're using their wrapper classes there, which isn't good when it's not really good practice when you don't need to use them as wrapper classes. Okay, but anyway, ignore those issues. So the float one will get called when you pass through 2 floats. The one that takes 2 doubles will get called when you pass through 2 doubles. Pretty easy stuff. But we've got the same code in 2 places. We could, of course, get rid of this one. It's irrelevant, but it's just a silly example. Pretend we need it. Okay, but we're going to try and combine these 2 methods into one now using generic method techniques. Okay. So 2 methods have the same name but different parameter lists. One takes floats, one takes doubles. And the 2 methods perform exactly the same output or results. And we could actually replace those 2 methods with one generic method. And it looks a bit strange. Instead of saying double or float, you put T there. There's some letters you can use that are common letters used, T, U, V, W, and so on. But T's the most common one. And then here, to tell Java that you're using generic data type for that method, or in that method header, you put a less than T greater than sign. Okay. So that just lets Java, you're dealing with a generic method, taking generic data, and T's going to be the variable name or variable type you're going to use. So it's just like, what could you pass? Okay. So the generic method can be defined inside an ordinary class and inside a generic class. So you can have generic classes or ordinary classes. So here we've got our overload test again. We've deleted our 2 methods that take doubles and floats. And down here, we're just calling the method again. Okay. So when it's doubles, like here, doubles get passed through as T, type T. And when it's floats, they get passed through and type T changes to be float. So this method is adapting on the fly to the data that's being passed through. If it's double, it'll take it. If it's string, it'll take it. If it's whatever, it'll take it. Okay, so let's just have a little bit more of a look at that. So this is the same code. I've just extracted it and put it in a file. What else could we do with that? Could we do strings, print marks? Do you reckon that would run? Anyone think that would run? Anybody not sure? Let's give it a try. Compiles and it runs. So we're passing through Mike and Frankie as the assignment marks. Okay, we're not doing any calculations here. We're just concatenating on the strings, so we can pass through anything we like. Let's see if we can pass through dates. I think I'm back again. Everything paused for a second. So now I'm passing through 2 dates. Who thinks that'll work? Hard to say. Okay. Anyway, let's see if we can compile it. Oh, we're gonna narrow there. New date. Oh, got to bring in dates, of course. Import java.util.date. Compile's okay. And it runs fine. Okay. So T, when you use T like this, it's wide open. You're not specifying what sort of data T could be. So it's any type of data. Okay. So pretty powerful stuff. We've reduced 2 silly methods down to 1 silly method, but it shows you how things work. It's proven the point. Okay. And of course, we could pass through, if we had employee declared, we could even, if employee class was declared and there was a 2-string method, we could pass through new employee. Okay, so we could pass through new employees. And over here in the method, employees would then be coming in, and here Java will be saying you need a string representation of that employee. So I'll call the 2-string method automatically for you. Okay, so we'd see Mike followed by the salary, followed by whatever on the screen, and then Frankie followed by the salary. Okay, so we can pass through anything we like, any type of data. Pretty powerful stuff. So if you find yourself doing this sort of thing, okay, so if you've written the same code basically 3 times or more, and you're sorting integers, and then you're sorting strings, and you're changing int to string, that's the only thing you've changed is change int to string in a data type, and then you string. You do it again for employees, and the only thing you've changed is you've changed string to employee or something else. You've only made very minor changes. Okay, stop. You know now to stop. Okay, so stop. Use generic. So if you find yourself doing this, anything like this, not just for sorting, but for anything you might be doing, stop, 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 and use generic methods techniques. Okay, so I'm hoping that's going to trigger in your brain and go, oh my God, I've got to use generic methods. And you'll come back and look, and you'll save yourself a lot of code, and a lot of duplicate code and a lot of testing and a lot of mucking around and a lot of people later on sneering at your code when they see you've written the same thing 3 or 4 times. So you save yourself some embarrassment as well. Okay, so keep these in mind. They're very good techniques. Let's just talk about a few things. So look very carefully at the syntax. The static doesn't matter. It's just that we've got a static method in this case. It doesn't have to be static method, but this T here is critical, as are those T symbols there. Actually, I'll add another will this work in, just a sec. We're going to that first one. So will that one there work? Is it okay? Is it okay to declare T and only use T for one of the parameters? You can say in the chat window if you want to say anything.
I think it is, but I guess you'll tell us.
Yeah, you're quite right. It is quite okay. Yes, this one's fine. So that's all okay. Okay, you've said the method's going to take generic data. We'll call it generic data, and I'm only using for one of the parameters. That's fine. That's perfectly fine. Okay, so this one here can be anything. It could be a date or a double or a float or anything, but this one here must be a string. Okay, so that's fine. Why not? We might not be doing it for print marks. We might be doing it for more useful things than that, but I'm just showing you for silly examples. Okay, what about this one? So I've used T there, but I haven't used it at all over here. Okay, so you won't know until you try it, but Java doesn't like that, okay? So you'll get a cannot infer type variable T, okay? So it'll be pointing at that saying it can't infer what that is. Is it a double? Is it a float? I can't tell because you're not using it over here. Okay.
It also seems pointless.
It seems pointless. Yeah, exactly. Yes. It's like you're saying you're going to use a technique and then you don't use it. Yeah. And then this one here. So I'm just showing you some examples because these are errors people commonly do when they first start with generic methods. They put a T there and forget to change those to T, or at least change one of them to a T. And then here we've got no dover here, no less than T greater than here. And it's got to go before the method return type. So it's got to go in here. And so again, you won't know because we've never done it, but again, you'll get an error saying, cannot find simple T. And you'll be saying, but it's right there. Why can't you find it? It's right there. But you haven't put it here, so you've got to put it, and it's fine. Okay. Until you do that, it's not fine. Okay, so you've got to make sure you get that syntax right. So if you're keeping a little notes file with snippets of code, put at least that header in there and call it generic methods. Okay, keep a little snippet of that. Okay, what if you need 2 bits of data? What if you need not just pass through everything of the same type, but you want 2 types of data to be handled? Well, then you can expand it further. So you can have multiple versions of a generic method, and you can also pass through multiple pieces of data as well. I don't like this way. There's a U there and nothing there. Let's go on to the next slide. I think there's an error on that slide. But you can overload these methods, so you can have multiple versions of print marks, even though it's generic. So in that method there, T is said to be the parameter variable. So T is whatever the type is. And the common letters you can use in Java, the common letters that are used, I usually stick with TUV. We don't get beyond 2 or 3 in this course, even for examples. So TUV and then EKS are the other ones. So they're the common ones that are used. You might think, why can't you use any letter? Well, give it a try and see if it works. If you're getting strange behavior, you know that letters are not allowed for some reason. But if you stick with TUV, that's all we're going to need for this course. Probably just TU new even. Okay, so then go on to the TUVs. Righto, let's do a quick TUV example. So we'll beef up our example here, and we'll make it so that we can pass through two types of data, T and U. And the first one's going to be U. Doesn't matter what order they are. I'll go U and T just to show you that you can switch things around. So now we've got an overloaded version of the generic method. This one can take just one type of data. It's all strings, or it's all doubles, or it's all dates, whatever. This one here can take two types of data now, whatever they might be. Okay. And again, that's having them like that and then having them different order. Here's fingernails on the chalkboard. I want to change them back, but you can have them different orders. It doesn't matter. I want to change them back. It's fingernails on the chalkboard to me. It's like, yeah. All my fingers are tingling. My eyes twitching. Okay, so let's invoke this one. And let's invoke this one. So how do we know which one's going to get called? Let's put I'll put a little message in here. So prints T on the screen. And here I'll say, I'll print T, U, so we know which one's being called. And we've got some errors. Have the same erasure. So we're not actually saying that they're different types. We're not actually pinning this one down to be just certain types of data. So really Java's saying to us, it doesn't know which one to call. Even though it's overloaded, it can't tell them apart. This one here takes one type of data. This one here can take two types of data, but this one here can do all of the work of that one, so you don't need it. Okay, so let's comment that out. And we could use this one now if we use a thing called type erasure, which we're coming on to next, but let's just use it like this for now. New employee, I don't have employees, so I'll take that out for now. I don't have the employee class local. And control T, so everything's still working fine. T and U. But here we're passing through two strings. That would have worked fine for that, two strings. But let's pass through a string and a date. Control 1, control 2, and we can do it. So we can pass through a string and a date, okay? Or a float and a double, or a whatever, an employee and whatever we like, okay? So if we comment this method out and put the old one back in, which takes only one type of data, it will still work fine. So T is just a placeholder for any type of data because we're not putting any restrictions on it at the moment. I recommend if you are passing through two types of data, that you use the TU method. Make them so they are two types of data. That's definitely going to be safer. I like that one much better. Okay, and of course, these data could be anything. So this could be not just single objects, but it could be an array list. Employees array list and something else nasty. Okay, so that would work as well. So we're passing through not just objects, but array lists of objects. That would work as well if they were declared. Okay, and then inside here, it would try and get a string representation of that array list. So if you've got a two-string declared in your array list, or for your array list somewhere, it'll call that. Righto. So type erasure, we'll go on to. So for every generic type, a corresponding raw type is provided automatically by the compiler. Okay, so you might put T there and Java might substitute something else that can work. You might put T with restrictions and Java will substitute something else that can work. Okay, so the code you write might not be the code that's being compiled into your class file, .class file. That's compiled by bytecode file. Okay, so the name of the raw type is the name of the generic type. Type parameters are removed. type variables are erased and replaced by their bounding types. Sounds pretty complex. It's not really. If there is no upper bound specified for the type, then good old object is used. So if there's no upper bound or restrictions, then Java just replaces it with object. Okay. And that's what happens when you do T. So we've got no restrictions or upper bounds there, T. So it just replaces it with object. And that's why this worked here with Mike and date. Because really behind the scenes, Java replaces this code with and it also replaces that code. They all become objects in the compiled code. Object, 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 because we've got no restrictions there. They can be any type of data. Okay. And okay, so that's the code there that gets created. Object looks really strange when you start seeing objects here because we don't really deal with objects directly usually. Okay, so we can pass through any type of data that is a reference type, because the parent of all classes in Java is the object class. Okay, and then so we're now calling the one that's object. And again, that will work through anything. So that's why it worked before for T and T when I was passing through string and date, because it does get resolved to object. That's right, it does get resolved to object. Okay, I wasn't putting anything in there to restrict what you could be. We're coming onto that shortly. Sorry, I jumped ahead a bit. Okay, so that still runs fine and runs fine. So we can pass through any types of data we like, even different data, because it still gets translated through to being object behind the scenes. We can just write the code like that if we prefer. Okay, and some people might find that's a bit clearer. Okay, you don't have to worry about what T is. What's T? What could it be? Okay, instead you can just pass through anything that's an object basically, or a reference type in Java. If you want to, this is what we're coming onto. I was talking about earlier. We're coming onto where you can place bounds on what the types these can be. So T and U can be only certain types of data, or T here can only be a certain type of data. For example, it can only be numeric data, or it can only be types of data that implements a certain interface. Okay, and that's an example here. So public static T, we're now saying it could be any type of data that extends the comparable class. Okay. So as soon as you do that here, we'll put the original back in. Actually, no, we won't. We'll create a copy of it. T extends comparable. So what we don't really know because we haven't done enough Java. But so what are the classes in Java that extend comparable? So there's the wrapper classes. Okay, integer, the uppercase integer, the uppercase double, float, and so on. There's all those number classes that are in Java. They all extend comparable because you compare numbers. There's also string, and there's also other ones as well. There's a bunch of classes in Java that are built with extending or implementing comparable. And so they've got a compare to method. Okay, so we can pass through any types of those sorts of data here. But if our employee didn't have a compare to method, we couldn't pass through employee. Okay, so we're restricting this down. It's only methods that implement comparable. There's no reason to do it here because we're just displaying the data, but we might be doing if A is greater than B or A1's greater than A2 and all that sort of thing inside here. If we're doing that, then we definitely need comparable, but it's just an example. Okay, so how does that change things? Everything still works. So for that, we know very clearly that date also implements comparable because you can use compare to for dates. So date. Okay, well, let's create a little class that doesn't. So class fish. Private int speed. Public fish. Speed 0. little fish class. It doesn't implement comparable. If we put the code back the way it was, so we don't have the restriction in place for comparable, and put the old code back in, that one there, we should be able to call this the fish. But there's no toString method in the fish class yet, so we'll just see that strange class name followed by the memory reference on screen. That's all we'll see. Okay, all good. There's the fish class followed by the memory reference, and we've got the end chips coming out. Okay, let's put in the new one with the restriction. So we'll take that one out, the original, and we'll put in the one with the restrictions, which is our implements comparable or extends comparable. So now we're going to take types of data which implement the comparable interface, which is the compare to method, which we've talked about previously. Now we should get an error. Okay. So it's saying print marks cannot be applied to the given types, and the issue is the inferred type does not conform to the upper bounds. And we know string's fine, so fish. And it's arguing about the comparable, saying there's something wrong with comparable. T extends comparable declared in method print marks. Okay, so it's saying something's wrong with one of those bits of data. It's not actually saying which one, but it's because of the comparable, and we can work out pretty quickly that it must be the fish because strings work fine. And so we need to implements compare to and extends implements comparable here, and so on, and has a compare to method down here. Okay, so that should now work. We need to return 0. We're not going to do comparing. We're just putting a dummy method in, return 0. Implements comparable. Helps if you spell it right. Comparable. And control 2. And now we've got no problems. Now the fish is working again. Okay. If we put a toString method in there, we'd have the data coming out instead of that horrible memory reference. Okay, so you can, and so that's where both the T and the U. Let's just be really clear. If I do that, Java thinks object. So any class, whatever you like, anything that's a reference type can get passed through. Okay, and if I say this, T and U, okay, then Java still translates that through to object. Everything gets straight translated. So there's no upper bounds restriction. It wasn't saying U could only be a certain type of data. Okay, so that's all fine. And let's do the other one. So that's the one we were implementing compare to. Yeah, well, that's even the shorthand way of saying it, just comparable, which looks really strange. Okay. In other words, it's saying any class that extends comparable or implements a comparable interface. And if I say this, just to do the one final example, T and then U. Okay, so here we've got any type of data that implements the comparable interface, followed by U, which is just any type of data. So it just becomes object. Okay, so pretty powerful stuff. That's generic methods with type erasure, how type erasure works, and where you can set upper bounds the type of data you can pass through. So let's say you wanted to do just numbers. You wanted to pass through just not things that were comparable, because comparable is too open, because they can pass through dates and strings and all sorts of things. What if we just make it just numbers? Okay, so let's do that. And do another version, and I'll put it right down the bottom here. This one here, just only numbers. We want only numbers. Okay, so we don't want anything else, just numbers. So what can we put there? Well, is it the parent of these two classes in Java, or parent of a bunch of these classes in Java, double and integer and float and so on, is the number class. Number implements, extends numeric. Number or numeric. Okay. And now it can only be double, integer, float, and so on. Any of those numeric types. So this shouldn't work anymore. This shouldn't work anymore. And none of those should work anymore. Okay, but the original two should still work. And again, we've got all these errors coming up. Cannot be applied to given types, string and string. Inferred type does not conform to the upper bounds, which is number. Same for the next one. Because we've got dates in there, same thing. They're not numbers, they're dates. Same for the next one, there's strings and dates in there and all sorts, and number. So it's picking on all those other ones. So I'll comment those out. Nice. We should be fine again because we're just passing through floats and doubles, floats and doubles. None of this code's active anymore. There we go, we're all working fine. Okay, so with a little bit of knowledge about how these classes connect up in Java, you can restrict it down so it's only classes that implement certain interfaces, or only certain classes that have certain parents. Okay, or certain places in the hierarchy. For example, there where only classes that extend number can go through. It's double, integer, float, and the other ones as well. Okay, so pretty powerful stuff. And again, this is just scratching the surface. There's a lot more we could do. Any questions so far? Okay, that's good, I hope. Hope everyone's...
Nothing at the moment.
Okay, thanks, mate. Hope everyone's going okay. Please ask questions if you're not sure about anything. And it's unless you're applying this stuff fairly often, especially when you get onto TUVW and the other letters you can use, you can get pretty confused pretty quickly. And because you can have restrictions on certain fields, like T extends comparable, but U doesn't, and V extends number, And so you can have different restrictions on different parameters coming in. And that's when things get much more complex. So, yes. So this lovely T, for example, there. We're now on slide 12. This lovely variable T here looks so nice and so inviting. And, oh, I can conquer the world with T. I can make anything work with T. Unfortunately, there's so many rules around it that you've got to be, there's not really that much you can do really in the scheme of things, which is really sad. But then also they don't want, Java's trying to stop you from being too crazy. It's trying to stop itself from turning into C, the C language. So it can be used for the method return type. It can be used for local variables and parameter types in the method header. So up here is fine. Here's fine. It can be used for local variables inside the method. That's fine. And there's not much else. Okay. So that's what it can be used for. The method return type, the parameter types, if you want to, and declaring variables inside the method. And that's about it. You know, so this is going back to the bounds again. I think we've so generic method may also need to place restriction on type of variables. So for example, here we're calling compare to, and that just means we've got to put t extends comparable in there to make it so it's only classes or class objects that extend compare to. The variable smallest has type t. So here we're declaring a variable called smallest and it's of type t. That's quite okay. We're declaring a single variable. Similarly equal to the first one in the array. That's quite okay. They're saying this is error prone because I haven't put that type restriction up here. T extends comparable would make that much safer. You could just cross that out then. Okay, but at the moment they can pass through any type of data, string or employee or anything, and it might not extend or implement the comparable interface. Okay, so, and it should be compared to, not compared. My finger was twitching and something was wrong. The smallest variable t is type t. How can it be ascertained that the class to which t belongs has compared to method? Well, that's where you put extends comparable in to make it safe. Then you're good to go. Note you use the extends keyword. It's quite strange. When you do that on a class header, it's public class, my class implements comparable. But when you do it inside the type bounds specifier, you say extends. So it's a bit strange the way Java switches between the two. That's the syntax. We just got to live with it. And this variable here, or this data type, doesn't have to just extend one class or implement one interface. It could have multiple. And so you could extend comparable and serializable and others, whatever you like. So you just join them all together with ampersand, single ampersand. So again, very strange syntax. If that was a class header, public class, comparable, serializable. It's an American product, so make sure you spell it with a Z. But in the T parameter, it's T extends comparable and serializable. So not only is the keyword changed, but you're using ampersand instead of comma. So it's really strange. And again, you just got to get used to the Java syntax. That's just the way it is in Java, I'm afraid. We haven't talked about serializable. We could spend a few hours talking about serializable. It's not something I want to get into. It's a huge topic. And it's a bit of a strange world too when you get in there. So restrictions of type variables, you cannot, so this is some restrictions. We've seen what you can do. You can use them here as return types, there as parameter types, and you can declare single variables of type whatever. You can't create new objects, so you can't say t smallest equals new t, that's not allowed. And you cannot construct a generic array. So t square brackets, no, not allowed. So you can't create arrays of them, and you can't call the new or the constructor for them. Okay. So some rules there. Also, type variables cannot be used in the catch clause. This is, if you start writing code like this, it's yeah. Anyway. So we've got T extends throwable. So it's anything in the throwable hierarchy, which is exception and error and runtime exception and all those errors, arithmetic, all those arithmetic exceptions and type exceptions, array out of bounds exceptions, all those sorts of things. Anything that's in a throwable class, throwable branch, and that's not allowed. Not allowed. Sorry, you're taking it too far. Even Java says enough's enough. If this is C or C++, yep, no worries. But not Java. Java tries to keep things a little bit more sane, a little bit more controlled. Okay, so there's two things you can do, or three things there, and there, and don't try and do anything else. Basically, that's about it. We might come. Oh, this is our final slide. So write a method called print array to print the contents of an array of integers. Write a method to print an array of strings. So we've got print array to print an array of integers, print array to print an array of strings, and then create a print array method to make it so it can print anything you like, strings, integers, or whatever. And then have a little tester class. Okay, so pass through an array to the method, and it will work out how big the array is and print out whatever. And so on. Okay, so we'll do that for activity. We'll have a 10-minute break, and you can do the activity as well. And we'll come back at 10 o'clock or 10:01, and we'll talk about it and see how we go. Okay, so do that for activity, and things will become clearer. Okay, see you in 10 minutes. Okay, back again. Can you hear me okay?
Yes.
Okay, thanks, Wayne. Alrighty, so this is, I'll show you what I've done. We can compare. So I've got the print array method for integers. Just takes through an array. If the array is not null, then we're safe to go. I'm just looping through the array, printing all the data on one line or as many lines as it needs. Just keeps wrapping, just comma separated. Then a print line at the end to clean up with the cursor on the last line. Print array with strings is just the same, exactly the same code. Nothing's changed in here. The only thing I changed was string. So as soon as you find yourself doing that, generic methods all day long. They're so easy to do. Okay, so I'll just show you this code works. There's my two arrays and my prints. Just show you that original code works. There it is. It's all working great. Let's now comment out these and make them generic. So I just copied and pasted the string version down here. Okay, so what's the first thing we do? Can someone tell me what the first thing we do is? Anybody?
Put in your generic type.
Yep.
For T.
Okay, so we'll put T there. And someone who's not Wayne can tell me the second part. There we go, Nicholas. Thank you, Nicholas. I appreciate it. Okay, so I'll copy Nicholas's code in. And there we go. Thanks, Nicholas. Okay, all good. Anything else we need to do? That should be it, shouldn't it? Because when we changed when we changed from string to int or int to string, all we did was change that one type there. So that's what we had to really change here. We also had to tell Java that we've got a generic method. The T means something that's generic. And that's what that means. Okay, so it's just signal Java we know what we're doing, and that's a generic type. And that should be it. We're good to go. Cannot be applied to given types. Inference variable T has incompatible bounds. So it's the int it's picking on. Okay, if we made it uppercase integer, that would make Java a lot happier, I think. Yes. Okay, so when you've got an array of ints, lowercase ints, you're talking about the primitive type. Here we're talking about any type of data that's a reference type, anything that can be referred back to being an object. So that means integer, the wrapper class version we need to do. Okay, so a small change here to our data, just make them all the uppercase integer, and that's it, we're good to go. Everything still works fine. Okay, so that's why in those examples earlier, if we go back to the slides, it was uppercase float and uppercase double. It wasn't the lowercase versions because the T can only be a reference type, and lowercase double and lowercase float aren't reference types, they're primitive types. Okay, remember we talked about wrapper types in the prior week? Okay, so make that integer and you're good to go. Any questions on that one? Ah, righto, yeah. So Nicholas has got some clever code here. He's used the arrays class in Java. He's used that. Let's have a look at Nicholas's code. Can't seem to run it. Okay, let's have a go. I'll comment out my one. Array. Can it be referenced? So it's got to be a static method because we're calling it from the main. We're not calling it for an object. Okay, and that's all good. But you don't need to worry about the loop. Here's our arrays. So Nicholas has reduced his code down to one line of code. Okay, which is great. So that's using a two-string method in the arrays class. And of course you don't have to write the code like that if you don't want to. That's with the that's called fully referenced or absolute referenced objects. If we just go arrays.toString, and we just do an import up the top. Do an import of that, and then you can just go arrays.toString down there. It's a little bit shorter code. That's all. Looks a bit neater. All good. Yep, so well spotted. That's a good one. The only thing I'd be careful of here is if I pass through this one here, check for null. Let's just see what happens then we pass through a null array. Null on the screen. That's not crashing. That's fine. Yep. So the toString method in the arrays class handles that. So that's fine. Very good. Anybody else get a different method or different way of doing it? Many ways to do stuff in Java. Many ways to do stuff. Okay. All good. That's probably the way most people got. Maybe you didn't get the if statement to check if it was null. That's just good practice. Check if it's null before you try and access the array. Otherwise, you'll get an array out of bounds or array is null. Try and access null object. All those sorts of errors coming up. All good. So we've done that, and we've done the tester class. Let's do it for an array of chars as well, just to prove it works for characters. Character, error4 equals, and we'll create an array of characters. So we're using single quotes now, not double quotes, they're characters. Teeny. We'll print that down here. Teeny's coming out. That's all good. So we can't use. Okay, so we cannot use int double boat float byte boolean or any other primitive types. You can't use those because they're not reference types. And here we're talking about reference types. Remember, T gets replaced by object behind the scenes. So you can only use reference types. So if you need int, use integer. Wrapper class version. Okay, so we spoke about wrapper classes and auto boxing and all those sorts of topics. We talked about those in prior weeks. Okay, so keep those in mind. So we've got a generic method, and that's really short, one line of code, beautiful. And the only drawback is we had to change our int to integer. Not a big change. Not a big change at all. Okay, that's good. Any questions on that one? Anyone got any questions or issues or not sure? Anyone got another way of doing it? Anyone got errors they can't fix? Okay, all good. So like I was saying earlier, should we also cover generic classes this week, which are a very similar topic to generic methods? And then next week, got all the next week to think about assignment 2, explore some topics. So this is where you get to come up to speed on these topics and ask questions next week, hopefully on generics. What you need help with. You know, you're trying to apply to your assignment 2, what you need help with. And I'd also discuss some strategies for dealing with array lists or arrays. So you can have just a single array list class instead of one for each type of, each hierarchy of data. And I'd like to also talk about these, even though I'm not supposed to talk about them. They're such a lovely little topic. I'll talk about those as well, maybe typed files. And okay, thanks, Wayne. Sounds good. So we must go ahead with generic class. We've got nearly a whole hour, so we might as well do it. Okay, generic classes. So I'll talk about generic classes, the type parameter, the restrictions and limitations, wildcards. There's a whole lot of rules again you've got to keep in mind. But if you don't stray off the narrow path or the tightrope, then you're going to be fine. We'll talk about inheritance rules and wildcard types as well. Okay. So generic programming means writing code that can be reused for objects of many different types. So for example, if you've got an array list class, if you've got an array list of employees, okay, and so on, and you've got code to save to file, load from file, search for employee, name, JText area or JTable, something like that. Okay. So save and file, load from file, search, get a list of them, employees into a text area table or anything like that. There's a whole lot of stuff you might do for employees. And then you've got an array list of something else, work history. And then you've got methods to deal with that as well. So you find yourself writing the same methods again. You're thinking, oh my God, there's got to be a better way. Okay, and of course there is. And that's where generic methods and generic classes come in. So, the way things are heading for Summit 3, you've got the 3 main classes. You've got the vehicles, you've got the owners, and you've got the accidents. So you're going to be writing this code, this same code 3 times, unless you follow the generic way. So I'm trying to save you work for Summit 2. It means a bit more thinking, a bit more practice, a bit more thinking, but you can save yourself a lot of code. Okay, so that's where we're heading, trying to make your life easy for Summit 2. And so an array list class can be used for handling collections of strings or files or anything. A generic class is a class with 1 or more type variables. The code for a generic pair class has been shown in the next slide. So this is generic pairs. Okay, so just pairs, we just made up a type of data called pair. It doesn't matter what it is. Okay, and with pairs, we've got 2 things. We've got a first and a second. Just whatever it is. It could be marbles, it could be employees, it could be fish, it could be products, it could be students, it could be whatever. Dates, strings, whatever. Okay, so pair T. So we've got that syntax again, that strange syntax. We're signaling to Java, we've got a generic class coming up, and it takes types of data of type T, just one type, one single type. Okay, so TT, you can use T here. See all the T's. Okay, so you can use them in return types. You can use them to determine the parameters, and also you can use them to declare what type of data your instance fields are. Okay, so all the usual things we're saying with generic methods still apply, but the rules haven't changed. Okay, you can use them for declaring variables of a type, the parameter types, and the return types of methods. Okay, and we're signaling there that it's a generic class because we've got this less than T greater than there. Okay, so generic class. So this class now has got a default constructor which sets them both to null, a parameterized constructor which sets them both equal to the bits of data that pass in, whether it's strings or dates or whatever. A get first, a get second, which returns the value of the first, whatever type it might be. It might be data, it might be string, it doesn't matter, it's going to return it. Okay, get the second, and then set the first to a new value. We're passing in new values, so we've got the accessor methods and the mutator methods for changing class data. So we're passing in new values and setting first equal to the new value. So we're not doing any validation or anything, we're just setting it to whatever. Okay, so pretty fun little class to have a play around with, and I'm dying to have a play around with it. So I might grab that code there and pop it into a little file. Week 8 pair.java. That's okay. Let's do a pair test. And I'll copy the print tester. Okay, so there's our pair class. Let's declare a pair object. Okay. Pair 1. So what type of data is pair 1? What are the instance fields? Well, what sort of data is in pair 1? Is what are the instance fields that are in the class? Let's go back over here. They'll have a value null, won't they? Because they're calling it the default constructor, which is calling the default constructor there. So that should be null. Okay, so if we go system.out, let's add a toString. Save ourselves typing the same code again. Public public string, public void. toString there, just added just to make it a bit easier for us. Plus public string. Here we go. And so we're system.out.println pair 1. Just say just converting pair 1 and calling the getter methods for each one. And then we're seeing null and null on screen. So we're seeing nulls, which is what the data was initialized to. Let's now create a different pair. Mike and Frankie, that's pair 2. And output pair 2. Mike and Frankie. Okay, so we've specified the type of data that it is. If we pass through, well, actually we haven't specified the type of data. We've just passed through strings. Okay, we haven't specified anything here. Okay, and if you have a look on that in that compile window, you'll see the excellent recompile with excellent unchecked for details. Java uses unchecked or unsafe operations. Oh my God. So something in that line of code uses unchecked or unsafe operations. And it's because we're not telling Java what type of data we're using. Okay. And we can do that with this sort of little chap here. We can tell Java what the T is. And that's where the thing over here comes in. String. We can say we're storing strings. Okay. So your code will still compile and run fine without it, but Java's worried about you. And it's going to give you this warning when you compile your code. If we put the string there, Java says, okay, you know you're dealing with strings. You know what you're doing. It's still not enough. Okay, and that's because we also need to use string over here. And everything's fine then. Okay, so if we do this, I'll leave the old code there. We get the unchecked or unsafe operations because we're not telling Java what type of data this is. Even though it's obvious to us it's a string, we can just reassure Java that we know what we're doing in the same way that when we create array lists or combo boxes, we've got to tell Java what type of data we're storing in the array list or the combo box. And otherwise you'll get those excellent recompile errors with unsafe, unchecked operations. Okay, so just string. We also use dates. Let's do a pair 3 of dates. And that's date, and I need an import for date, import Java util.date. Date, and we'll say new date, and print pair 3. Everything compiles and everything runs. Okay. Anyone surprised by that? Because the pair class doesn't bring in date anywhere. It doesn't bring in a date class. So how does it know how to deal with dates? This is the only class that deals with dates. Okay, it's anyone with the import in it. And the code still works fine. Okay. I think that's very interesting. So Java is doing stuff behind the scenes to look after us, and it is making sure that this class here knows what a date is. Otherwise, we get compilation errors. I don't know what a date is. Okay, so pretty interesting stuff going on there. That's the old one. That's a new one. And we'll bring back our little fish class just for this. I'll put it in its own file. New fish.java, fish.java. Just have another class to make an object of, that's all. And I'll add a toString. So now we can use it in our pair test. Let's create an array of fish or a pair of fish. Pair 4, 4 and 4, and fish, and new fish, fish. And then we've got the fish coming out, fish and fish. Okay. So you might be thinking, well, that's interesting, but I mean, that class is useless. And you're right, it is pretty useless. It's just a silly example class to create a pair of objects. Why? Why do it? Okay, so it's just an example. Okay, it's just showing you how things work. What if we needed to do, and this is what I was referring to a little bit earlier, where I went down a rabbit hole a bit. What if we needed to do this? Pair 9, and we'll take off those parameters again. Okay, because we're going to do multiple types, and we'll do a new date or new fish, and it's pair 9. Okay, so when we do that, we're not just dealing with one type of data anymore. We're dealing with two types of data. We're dealing with strings and fish. And we're trying to shoehorn those into a generic class that can only take one type of data. So when it does its replace by object, will it work? Let's have a try. Again, we've got the unsafe operation. That's okay. But everything's working fine. Okay, so it's still just doing the replace by object. T just becomes object behind the scenes because we're not doing any bounds specifying on it to say it can only be numbers or can only be classes that implement comparable. And so again, it's just object behind the scenes. And if you have a look at the code Java generates, it is just object, 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 object. Object goes everywhere. Okay. So if you don't like writing a code like this with the T's and that, you can just make it object if you want to. Okay. But the T becomes useful because you can then do extra things. We'll come on to that a little bit later, where you can specify things a bit better than you can with object. It's bounds checking and things you can do pretty easily. You can still do it with object or comparable or whatever, but that works fine. So T doesn't have to be one type of data. But of course we've got those nasty warnings coming out, which are pretty ugly, really. You don't want to write code to go into production with those sort of warnings. So what do we make it? We can't make it string because fish isn't a string. We can't make it fish because string's not a fish. maybe that's about all we can do. Is that enough to keep Java happy? Let's watch the compiler window. And that's enough to keep Java happy, okay? At least you've told me what the data is. It's an object. Even though object means anything that's a reference type. Okay, so even that's enough to keep Java happy. Right, get rid of that. Back to the slides. If you want to be able to specify two types of data, okay, and have it so you can specify things rather than just saying it's object, which is really, really horrible way to do it. You want to be able to say it's a fish in a string, okay, then you can use the two letters. So T is the first and use the second, And then you have T and U, and the same rules apply. So the methods in here can return T or U. You can declare variables of type T or U, and your instance fields can be type T or U as well. Okay, same rules apply. Okay, so if you've got more than one type of data you need to do, and you don't want to pass through object, which is, this is horrible. Don't write code like this. It keeps and maybe that's a bad thing to keep Java happy and hide the warnings like that, because that warning was actually doing you a favor, saying you're writing code here that's not really safe. You've got two different types of data and you're trying to shoehorn them into T. Okay, so let's now make it a pair with two types. So I'll make it with, I'll say this class is pair two. Pair two. Okay, pair two, that'll do. Pair two, so it's pair two, pair two, pair two. And we've got T and U. T and U. And T and U. And get second returns U. Set second takes a U. Looks pretty good. So now we can have two types of data properly, not the bodgy, horrible way of shoehorning object in there to keep Java happy, or to shut Java up, basically. That's what it's really doing. It's shutting Java up to stop them from warning us, which is bad. Much better solution is to use this pair two class where we've got two types of data. So now we can do pair two properly. Pair two, string, fish equals U pair, and I'll call it pair 20, and it's going to be string and fish as well. We're doing things properly here. No need to put object in there to bodge the compiler warnings to stop or anything like that. Okay, so this is doing it properly. String fish. New pair two, sorry, pair two, pair two, pair two. There we go, so everything's working great here. Horrible, bodgy code. Bodgy. And this is a much nicer way to do it. Much better. Okay, so instead of just throwing everything in the object pigeonhole, do it so you're doing it properly with the types of data you want. Unless you want things to be wide open for some reason. If you want things to be wide open, you want to be able to store anything in there, then that's probably about all you can do. But if you want to narrow things down to limit it just to strings and fishes, that's the way to do it. This might be okay if you want to be able to store anything anytime, but just keep in mind it is dangerous code when you start dealing with object directly. Okay, so that's where you got we got pair one where we had only one type of data, but it could be object. Okay, one type of data, but it could be string, or it could be date, or it could be employee, or it could just be object. You could just say object and pass through anything. And we got pair two, where you got two types of data. But again, you could have object and object. That means anything you like as well. Okay, but it could be string and fish, or employee and date, or whatever you like. Okay, so you can see already we're starting to make inroads here. Okay, so instead of having an array list of employees, maybe we can have and all that data in an array list class for employees, or for the array list of employees. Maybe we can make a generic array list. It can take anything. Okay, so that's where we're sort of heading. You don't have to do that for assignment 2. It doesn't say you must write generic code for assignment 2 and generic methods to generic classes, but it's good if you can to try and apply the stuff that we're covering. Okay, so that's what that example there is. Recall that local variables can be used for many purposes in a generic method. In a generic class, the variables can be used for the types of fields, same thing, types of fields, the types of local variables, and the method return type. The rules haven't changed. The generic class acts as a factory, and they're sometimes called factory classes for ordinary classes. So it's acting as a factory for ordinary classes. And the generic type can be instantiated by substituting the types for the variables. So you can have pair string, pair double, pair object if you want to make it anything. If the generic class is instantiated as pair string, the entire class can be thought of as doing the substitution. Okay, and if you made it pair date, all of those strings will become dates. Okay, so that's a good way to think of it. Is that I'm just using substitution. Whatever I declare pair as, pair test. So whatever I declare the array to be, or the pair class to be of, date or fish or string, then that's what gets passed through, and Java does a substitution. Think of it that way. Okay, so that the class then becomes just for that type of data. If you do pair object, then it's wide open. Anything can be stored that's a reference type. And if you double, it changes it to double. So that's a good way to think about it. Okay. Here we've got a pair of our pair class just as before, and we've got a pair tester, pair string a couple equals new pair string line and line s, and we're just using the getter methods to get the first and then get the second. Okay, but I've made that toString method to make it so it's a bit shorter. One thing else I should say probably is with Java 7 onwards, pair 14, you could leave the second fish out. Okay, so that was a slight shortening of code that was okay with Java 7 onwards. And that will still work. Pair 14, it's still fine. Okay, so if you leave the first one out, that's when you get those compiler warnings coming back saying uses unsafe or unchecked operations. If you leave that one out as well, you'll get that coming back in. Oh, and so you can't leave that one blank at all, but if you did that, wow, okay. Gee, that's interesting stuff, isn't it? So if you do that, okay. If I put the less than greater than back in there, Java doesn't warn you anymore. Very interesting. I don't recommend doing it. I recommend specifying the types when you can. Okay, so that's good. And I like giving the second one as well. I just like making it really clear. It's fish and fish. Okay. Much better. Okay. Okay, so here we're using the pair class with an array class, just for a bit of fun. Okay, so we've got an array of strings where we're looping through the array of strings. We're getting the min and max, and then we're using compare to get the minimum string and the maximum string. Okay, using compare to, so it's compare to, not compare to ignore case. That's using the compare to method. And then at the end, we're creating a pair object based on the min and max. Okay. So if we pass through that array list there, what would be the minimum? What would be the minimum string in that list? In other words, alphabetically the least. Remember your ASCII table. You got the digits, and you got something, and you got something. Okay, so uppercase Mary would be the least, because that's uppercase letters. And then out of these, which should be the greatest or the maximum, and it will be the little. Okay, so we should see Mary and little come out if we run that code. Okay, so first should be Mary and second should be little. Okay, if we change it to compare to ignore case, then it would be A and Mary would come out. Okay, so silly example, just showing you how you can use it, that's all. We might leave this till next week. Or the end of the lecture anyway. We'll see how we go. Translating generic expressions. When the program invokes a generic method, the compiler inserts a cast when the return type has been erased. So pair employee buddies equals whatever, and employee E1 equals buddies.get first. Okay. So this is quite okay because we've declared the pair to be of type employee. Okay, so when get first returns, it's not returning an object, it's returning an employee. So there's no need to do a casting here of round brackets employee. Okay, because we've already explained to Java that the pair is of employee. Okay, so that's quite okay. There's no need to do a typecast saying employee inside brackets. And you can also, if you had to access the data, if the data was public, then you could access the data as well. Then that'd be quite okay because we declared. Remember the substitution happened, and it treated it as double or string or employee, whatever you declare. So that's really an employee, and that's really an employee if you make it pair employees. Okay, and that's returning an employee. So there's no need to do any typecasting at the end. That's all that's saying. In a long-winded sort of way. Restrictions, you can do the same sort of restrictions as well. So you can't use primitive types. That's not allowed. Double, int, all the lowercase primitive types, no. But you can use the wrapper types or the auto boxing types. Uppercase double, uppercase integer, uppercase character. All those sorts of ones, they're fine. And you can also do some checking as well. So you can say if A is instance of pair string, then that's not allowed. So you can't do that. Okay, it looks like it might be allowed, but if A is instance of pair string, not allowed. Okay, but what you could do is you could get the data out of the string. You could call get first, and then check what sort of data that was that came back. But you can't do it on the class as a whole. It's not an instance of pair string. Okay, and you certainly can't do the generic pair T either. So sadly, they're not allowed. It's a bit of a shame. Okay, but there are ways around it. Like I said, you can do this. This is slide 13. So you can say if A That would be quite okay, because we're getting A from the first, which is a date, because we declared the pair to be of type date. And then you can say if A is instance of date, that's quite okay. Okay. Instance of. Okay, but you can't say it directly. You can't say if pair D is instance of pair date. Bit of a shame that. I thought that was a pretty strange limitation to enforce, but I suppose they've got to draw the line somewhere, don't they? So, so that's not allowed. You can't say if it's directly of pair string. You cannot do arrays. So you can't say pair string square brackets table equals new pair string 5. You can't declare an array of pair string objects, which is a real shame again. And you cannot construct a generic array. For example, T square brackets local array equals new T2. You can't do that. A whole lot of limitations you can do. You basically got a fine line you can walk down. You got to keep the rules in mind. So these generic methods, generic classes provide a lot of power, but there's also a lot of rules go along with it because they can be so dangerous if the rules weren't there. Okay, so singletons. There's so much we don't talk about singletons. So a singleton is a class that can be instantiated once only. Okay, so if you've got an application that creates class objects, then a singleton can only be created once in your application. Okay, so it can only be instantiated once. So we don't even talk about those in this course. I'm not even going to talk about them again. So you can't have static. Just think about you can't have static. They can only be instance fields. So static's out. And you can't return static types. You can't have static methods returning T either. So it's only instance fields and instance methods that can return T or be of type T. You can't have them for static fields and static methods. And again, you can't do the throwable thing with catching for T either. That was what we saw with generic methods as well. Okay. So a whole lot of rules there, grab bag of rules. And so with the power, you get a whole lot of restrictions, but it's to keep you safe. Inheritance rules. Okay, so again, some strange stuff happening here. Pair S and pair T are not related, no matter how S and T are related. Okay, so you've got employee and manager, you've got a relationship. Manager is a type of employee. Manager is an employee, you've got that, is there a relationship happening? But between pair employee and pair manager, there's no relationship. No relationship at all. Okay, so you can't say if you can't do any tricky inheritance stuff with pairs or whatever the class is. It doesn't have to be pair; it could be any class. But any generic classes, the inheritance relationship is lost. Okay. Bit of a shame. There's so many shames. I think it's things I think, oh, what a shame, but oh well. You can also do wildcards. So we cannot pass manager to, if we've got a pair that's set up for employees, we cannot pass a manager or use a manager in that class because there's no hierarchy anymore. The Java doesn't recognize there's a hierarchy between them. But if you use a wildcard parameter, then the type's allowed to vary. Okay. Okay, so this gives us a pair of employees. Employee first equals p.get first. Employee second equals p.get second. And we can print them out, call toString, whatever we like. We're taking through a pair of employees as an object. Okay. But they've both got to be employee. One can't be manager. But if you do this sort of notation, you can get around that limitation. Okay. and it's strange notation. It's question mark extends employee. Okay, so what this method now can take is anything that's employee or below in the hierarchy. So now Java's suddenly recognizing the inheritance relationship between employee and manager. It's allowing it now when you use this wildcard notation. So question mark extends employee means you can make a pair of any, or pass through a pair of any data class that's employee or manager or anything below employee in the hierarchy. Okay, so that does get around some of the limitations a bit. So this might be useful, for example, I don't know, maybe in a future assignment when you've got an array list class of vehicle and you want to handle other types of vehicles. Maybe. I'm just throwing that out there for a quick example. Okay, so now we can say pair manager, that's okay. Pair double, not okay, because double is not part of the employee hierarchy. Okay, but we can pass through a pair of any type, of one type of data, but it's got to be something that's employee or below. So we could pass through a pair of managers or a pair of employees. Okay, but pair double, no. Pair string, no. Pair date, no. Sadly, the following code is not allowed. And it does look strange. Question mark T equals P dot get first. You can't do that. You can't say, you can't use the wildcard there. Okay. So with every thing where you think, oh, that's good, there's another thing where you think, oh, that's a shame. Super type can be specified for wildcard as well. So question mark super manager. Okay. So now the wildcard's restricted to all super types of manager. Okay, so extends employee meant employee or anything below. Okay, and super manager means anything from manager up. Okay, so you can specify the restrictions going down the hierarchy, and you can also specify going up the hierarchy. Okay, so anything that's a super type of manager. So that includes employee, and it also includes object. Okay, because public class employee, we don't specify a parent, so then the object class is a parent of that class. So this also includes object. So be careful of using that because it might include things you don't mean to include. This one's much safer, I think. It's forcing it down the hierarchy, which is limited. Forcing up going up the hierarchy, not so limited. You can end up in all sorts of wild territory. So employee is a super type of manager. A pair employee of even pair object can be passed to the following method. Okay, so we're expecting anything that's a super type of manager. Anything that's super type of manager, so manager, employee, or object. So we could pass through a pair employee, or a pair object, or a pair manager, or anything's between manager and employee, or up the hierarchy, even higher if there's something above employee, if we add something in. Okay, so again, pretty powerful stuff, but there's rules and restrictions. Wildcards with super type bounds allow writing to a generic object. Wildcards with subtype bounds help reading from a generic object. Writing and reading. Okay. I don't think we want to say too much about that. That's sort of getting into other deep territory where, yeah. Okay, and that's about it for this week. So we've covered the generic methods and generic classes. We've talked about other things as well, like factory classes just in passing and singletons just in passing. These are whole topics in themselves, really, whole onion topics in themselves. Is there any questions on what we've done? So just the meat of it. So before we head off, any questions anywhere?
Nothing at the moment.
Nothing at the moment. So there was an activity a few slides back. I won't try and attempt that now because we've got people leaving for the next class. But have a practice, have a go of that before the tute, and then that'll get you up and running really fast for the tute. Or if you don't get time and you want to bring it along to next week's class and we can discuss it then, that's fine as well. So, okay. But thanks for coming on, everyone. Thanks to Amy and Wayne and Nathan and Nicholas and everyone else who joined in. And have a great week. Start thinking about your assignment 2 now. We'll read assignment 2 spec next week, and we'll start sort of trying to plan out things. And I'll start giving you hints and things you can try and look at to try and shorten your code if you're feeling up to it. If you think it's all beyond you and you just want to do the most basic way, stick with the most basic way. Just get it working. As long as you satisfy the spec, you'll be fine. But if you want to have a crack at some advanced stuff, some generics, you'll definitely want to come along to next week's class and we'll talk about things and try and explore things. I want to try and shrink your code down. Okay, it's always fun to do. You end up with a lot of code like that and you can shrink it down to that. It's nice when you see it happen. Okay, but thanks for coming along and have a good week and see you next week. Take care.
Thanks, Mike.
Thanks, Wayne. Thanks, Amy. Thanks, Nicholas. Thanks, Damien.